Hello students, welcome to Educate. In the last class, we have discussed about the preparation of aldehyde and ketone. In that, we have firstly discussed about the common method for the preparation of aldehyde and the ketone. As well as we have also discussed about the special method for the preparation of aldehyde. Now in this video, we will discuss about those methods by which we can prepare only ketone. Let's see. First one is by the Grignard reagent. How's that? It's the CdCl2 here. When the Grignard reagent will be treated with CdCl2, that is cadmium dichloride. So what happened here? Cadmium is a metal and chlorine is non-metal. Here, suppose this compound here, CH3CH2. This one that react with CdCl2. What happened? Magnesium will combine with to this chlorine from MgCl2, and then after this one here, this Grignard reagent. So this alkyl part will combine to this cadmium. So what happened here? 2 moles of propyl magnesium chloride, that is a Grignard reagent. The 2 moles of propyl magnesium chloride will treat with 1 moles of cadmium dichloride. So that in that case, magnesium will combine with 1 chlorine from MgCl2, and the carbon of this alkyl part will bond to cadmium. So as a result, there will be formation of dialkyl cadmium. There will be formation of dialkyl cadmium. Now, in that dialkyl cadmium that will form, in that dialkyl cadmium when reacted with acyl halide, suppose this compound, then what happened? This cadmium will combine with, so 2 moles of this we will take 2 moles of ethyl chloride here. So chlorine will bond to this cadmium. So there will be formation of CdCl2. There is 2 alkyl part and there is 2 acyl part and 2 alkyl part. So 1 alkyl part will combine with 1 acyl part, and the other alkyl part will combine with another acyl part. So compound will be this will be, and like that 2 moles will form. That is first method is that. Now let's see another method. From nitride, what happened here? Let's see. Bonding between this carbon of benzene, the bonding between the carbon of benzene and the magnesium is covalent. So bond will dissociate from here. In the nitrile, carbon is the positive part and nitrogen is the negative part. So here in this one, magnesium is the positive part and phenyl group is the negative part. So magnesium will combine to this nitrogen and this phenyl part will bond to this carbon. So when that has been added here, so triple bond will convert it to double bond. So that's why here when this magnesium MgBr has been bonded to this nitrogen, this one, and phenyl part has been bonded to this carbon, and triple bond has been converted into double bond. Now pass water, acidic water here. Actually water here is acidic water. So that dissociates into H plus and the OH minus ion. So in this case again, nitrogen is the negative part. Among carbon and nitrogen is the negative part. So hydrogen will go to this nitrogen and OH will go to this carbon. Same another water molecule will be there. So here that's steps I am writing here. So what will happen? Here to the nitrogen MgBr, there will be hydrogen. One hydrogen will bond to there and one OH will bond to this carbon, and here That will be the product. Again, that will react with water. So water means H plus and OH minus ion. So when hydrogen H plus will bond to this one, so that become, when hydrogen will, so that converted to NH2, then bond will dissociate from here. So there with NH2 is bonded to that magnesium, and that magnesium is bonded to bromine. So this will form, with the magnesium, one amino group and one bromide group will be bonded. So that is here. And now OH part will bond to this carbon. So here also the two OH group will be bonded to the same carbon atom. So that will release into H2O. So this oxygen will do double bond formation here. So ethyl, that means there will be formation of ketone. This will form. There will be this oxygen and this carbon. There will be double bond here to this acylic carbon atom. One side there is ethyl and one side phenyl. So one side ethyl, one side phenyl. That is, when you will practicize by yourself, then that will remain in your mind. And if you will try to only mugged up, you will only apply the effort and you will not get the result of that effort. So the manner in which I am telling you to predict the reactions, in that manner you should practice also. Now then after is, next question is from benzene or substituted benzene. So what happened here, about the Friedel-Crafts alkylation, you know, in the benzene, to every carbon atom there will be hydrogen. To every benzene, every carbon there is hydrogen. So what happened? This chlorine combined with any one of the hydrogen form HCl. So this acylic part will bond to that carbon. That is the product. Okay guys, easy? Now let's see about these questions. You will have to write following reagents to transform. Watch out here, hexanol to hexanal. So here alcohol, you will have to convert alcohol into aldehyde. So any mild oxidizing agent you can take. So one of the example is pyridine chlorochromate. This one is pyridine chlorochromate. Structure is like that. The structure of this pyridine chlorochromate is that. So one of them pyridine. So pyridine structure is like that. So that is bonded to chromium trioxide here, and the chloride ion also. That is PCC, pyridine chlorochromate. So one of the example is pyridine chlorochromate, or you can take any mild oxidizing agent like CrO3, chromium trioxide. But the advantage of pyridine chlorochromate is that if there be unsaturation at any places, if any carbon is unsaturated, then the pyridine chlorochromate will not affect that carbon. And CrO3, and here no unsaturation, so you can take CrO3 also. Second one is, here also it is alcohol and you will have to convert it to ketone. So alcohol into ketone, and it will be 2-degree alcohol, because cyclohexanol is like that. Cyclohexanol is that, so it is 2-degree alcohol. So when you will oxidize that, like CrO3, or here also that one, so this convert into 2-degree alcohol will convert into ketone. This is now here 4 parafluorotoluene to parafluorobenzaldehyde. Let's see. This one. So you can react with chlorine here firstly. So you this one directly from firstly react with chlorine, or you can use etard reaction, whatever be that you would like, etard reaction you do, or you do reaction with chromolyl chloride by any way, that means by side chain chlorination followed by hydrolysis, that also you can do. So what's the written here? Third, CRO2 produces acetic anhydride. Okay, CRO2 Cl2 and H2O, that's also you can use. Okay, this one also by chromolyl chloride and water, or CRO3 in presence of acetic anhydride. So about that reactions you have already studied. Now next point is ethane nitrile to ethanol. You have drawn, and that is firstly you reduce the ethane nitrile and then after you react with water. So then that will be allyl alcohol to propanol. So here there is already unsaturation in this alcohol. You will have to convert an unsaturated alcohol into aldehyde. So in that case, you will have to take PCC, pyridine chlorochromate. You will have to take, because if CRO3 or any other oxidizing agent you will take, that may affect the unsaturated carbon atom. But when you will take PCC, that is pyridine chlorochromate, then the pyridine chlorochromate will oxidize the alcohol into aldehyde, but will not affect the unsaturated carbon atom. So that's why here also PCC, pyridine chlorochromate. This one, due to this one ozonolysis, you do that ozonolysis followed by water. This reaction very easy. Chlorine will combine with any one of the hydrogen, form HCl. This carbon will bond to this carbon. So structure will be that will be the product. About these reactions, right now we have discussed here. Alkyne we have discussed already. CRO2, this one we have discussed. Now let's see about physical properties of aldehyde and ketone. Physical properties, about that we have already discussed that among aldehyde and ketone, aldehyde will possess greater boiling point because aldehyde molecule is more polar. So the molecules of aldehyde will be bonded with each other through dipole force. So that means there will be, that is aldehyde is more polar, that's why that will have greater boiling point. Same aldehyde will be also miscible in water. Lower member of aldehyde and ketone will be miscible in water because water molecule can do hydrogen bond formation with the molecule of aldehyde or the ketone. And among aldehyde and ketone, the aldehyde will be more soluble in water because the aldehyde is more polar. So that's why the extent of hydrogen bonding will be more in case of aldehyde compared to that of ketone. Okay. No need to mug up this one, molecular mass and boiling point, what will be there, no need to mug up. Here this one has been shown that why that will be miscible in water. So water molecule can do hydrogen bond formation here, that's why that is miscible in water. Now watch out this question. Firstly, I am giving you 1 minute time, think over that. Now watch out this question. As it is very easy, aldehyde, alcohol, ether and hydrocarbon, alkane. So alkane will possess least boiling point. Then after ether, then aldehyde and then alcohol. So that is written here. That they were the based on the method about which I have informed you. Watch out this question here. Same in this compound also. This is aldehyde, alcohol, ether and alkane. So alkane will be increasing order. So that will be alkane will possess least boiling point. Then after ether, among aldehyde and alcohol, aldehyde will possess less boiling point than alcohol, and maximum alcohol molecule will possess maximum boiling point. So order will be firstly alkane, then after ether, after that aldehyde, and highest will be of alcohol. Okay, that was about the special method for the preparation of ketone and the physical properties of aldehyde and ketone. In the next class, we will discuss about the chemical properties of aldehyde and ketone. It's all for this today class. Thank you, Team Educate.